We will continue with our next presentation. We are going to shift a little bit. We've been talking about energy efficiencies, and you've heard about energy efficiencies with air conditioning systems, and now we're moving over to energy efficiencies with sustainable and high-performance roofing, the 5 E's of high-performance roofing. And we have two gentlemen here today that are going to help us understand all about high-performance roofing. I am going to introduce you first to Dr. Manuel Gomez, Jr. He's a former superintendent of schools with construction background, including energy efficient and sustainable roofing materials. He is a public relations representative with Parsons Roofing and works hand in hand with consultants, engineers, and project managers that specialize in energy efficient, high performance, flat and low slope roof systems. Along with him, our other presenter is Mr. Phil Gustafson. He is a roof consultant and holds a Bachelor of Science in Mechanical Engineering from the University of Texas and is an expert on energy efficient roof systems for the commercial building industry. He specializes in sustainable high performance flat and low slope roof designs with over 200 projects and 3 million square feet installed in the last 4 years with Parsons Roofing. Please help me welcome Mr. Gustafson. See, I'm messing it all up now. Gustafson and Dr. Gomez. Thank you.
Good morning. Thank you, Ms. Franklin. Looks like you've got everything very well lined up, and I appreciate your invitation for us to be here today. There's been no humor this morning, and I want to put just a little bit of humor into what we're doing, okay? Yes, this is serious business, but we still have to keep the jovial side to it. One of the ways that you can tell yourself that you are aging is when you face a crowd like this one and you don't recognize faces anymore. I do recognize a couple of them, former County Judge Edgar Reese, and I think Ms. Casas just walked out. I recognize her. I'm getting to know some of you because I've only been with Parsons Roofing for a year and a half, and you'll remember me. I wish I knew your exact positions with your entities. This is the entirety of my presentation right here. I've got all my notes on this piece of paper. Most of what I would like to say has already been said, but as an educator, and I'm like the Marines, once a Marine, always a Marine, once an educator, always an educator. And what I want to do when I go to an entity is educate the owner of the building. You guys are the owners, okay? Educate yourselves as to what you want. Don't wait for someone to come and tell you what you want, okay? There are certain segments that dictate what you need, but you need to educate yourselves. That's what we're doing here, is educating you. Whenever you go out for bids, be sure that you ask for alternates. Don't set on just one, okay? I wish I could go into the rest of it, but call me and I'll talk about it. What Phil is going to talk about, now he's got a 2-hour presentation, so I'm only taking 30 seconds out of that. He's going to talk about energy consumption. What he's going to talk about also is upfront costs. Roofing costs are anywhere from $8 to $12 a square foot. We talk about cutting that in half with this kind of product. We have a healthy environment. We have a learning environment. With the new type of roof, there's very little maintenance. I remember as a superintendent, we used to budget 25 cents a square foot for maintenance. When you apply this kind of material, you can still budget 25 cents a square foot, but you're not going to use it on this new type of roof. You can use it somewhere else. Marco was talking about cost recovery, and so at this stage, now I'm going to turn it over to Phil. Remember, he's got a 2-hour presentation, so be sure that you brace yourselves for his 2 hours. And Phil, I'm going to change over to you.
Well, my name is Phil Gustafson. I'm with Parsons Commercial Roofing. The presentation I'm going to give today is a presentation that was put together by a gentleman by the name of Drew Belinsky from Duralast Roofing. Duralast Roofing is a company that was actually formed in 1978, and they were one of the first companies to bring to market a cool roof system. Back in the late 70s, it wasn't called a cool roof system, but they developed the original white roofing system based on the fact that it was originally a pond liner for toxic waste ponds, and they decided to bring it to the marketplace as a roofing. So that's where this presentation comes from, but I'll stay away from the Duralast aspect of it and just cover basically the ideas that were introduced in the mid-90s about sustainability and the cool roof technologies that are really one and the same, especially when you're talking about the PVC roof systems as Duralast makes here. People talk about the fact that this is a new roofing technology. The cool roof technology is new. I guess if you were to go back centuries ago when people had thatched roofs, they would look at the vinyl systems or the single ply systems and say, yeah, that's pretty exotic. But they've been on the marketplace for 35 plus years. They're proven systems, and they're meeting the needs of the LEEDs certification folks and the Green Global Councils and the different people that are trying to get more energy efficient roofing system and basically better building envelopes. So I'll just go into that real quick, and I'm going to make sure I've got this thing correct here. All right, I've got to stick this up according to the folks at Duralast. This is a protected ball, that good stuff. Everybody knows about that. Make sure I'm going the right way here. There we go. Okay. What are we going to talk about today? We're going to talk about and try to understand how cool roofing is an important element of sustainable roofing. Identify key attributes of what a high-performance roof system is. What makes a system a high-performance system? We're going to describe the 5 E's of the support goals for sustainable roofing, and this is something that Duralast developed, and I'll go into each one of them. It has to do with, they've just labeled 5 different things that make a system a cool, energy-efficient, sustainable roof system. And you'll also learn a little bit today about how to kind of have a practical checklist of how to determine if a roof system is a high-performance, cool, sustainable roofing system. Okay, what is cool versus sustainable? Well, like I said earlier, both of them emerged in the mid-1990s, and the idea of cool is, if we think about the white versus the black car in the parking lot, which one are you going to make sure and not lean up against? Of course, the black car, and we correlate that to the ability of a material to have reflectivity and emissivity, or emittance. And reflectivity is basically the ability of a material to reflect the sun's rays. Most single-ply roofing systems and most of the regulations that are written today for cool roofing specify approximately 75% or higher reflectivity ratings for the material itself. Then you talk about a term that most people don't understand, and that is the terminology of emittance or emissivity. And what emissivity is it the ability of a material to release heat back into the atmosphere. In other words, so that it doesn't hold heat. When you put something in a cooler, you want it to stay extremely cold. But if you have something like a roofing material, you actually don't want it to hold heat. You want it to release the heat back into the atmosphere. So those two things make up something called the solar reflective index, which a lot of people use to correlate to roofing systems. But we're going to stick mainly with the reflective and the emissivity properties of the white roofing systems. Okay. So the question is, and this conference is all about sustainability, and a good definition of sustainable roofing systems came from the Sustainable Low Slope Roofing Workshop at the Oak Ridge National Laboratory back in '96. So like I said, this has been about 15 years ago. And basically what they said is, and the statement that they put out about it is, sustainability involves avoiding or minimizing the impacts of a building and on its occupants and the environment, both local and global, from design to construction through maintenance, rehabilitation, and eventual demolition, with an emphasis throughout its life cycle on using natural resources efficiently. So that is the ultimate objective for both cool and sustainable roofing, is basically optimal performance from the time it's manufactured until the time that it's reached the end of its usable life and what is done with it after that point. So what's the next step in this? Well, sustainability and profitability go hand in hand. My boss reminds me on a very, very regularly that we are not a nonprofit company, and for a product to remain sustainable, the companies that are producing it or the companies that are promoting the sustainability have to be profitable. So just a couple of points about sustainability and profitability. Most often, sustainable products are within the green or the green design marketplace. And it's basically, sustainability is good business sense. If it wasn't good business sense, very few of you would be sitting in here today. It's all about common sense and being smart about the way a product is manufactured, its performance across its lifetime, and then the ability to dispose of it or to recycle it at the end of its life cycle. Green goes along with that. That's just part of the definition. All right. Sustainability leads to high performance, and profits are the key to sustainability. We talked about you've got to be profitable to be able to continue to have a sustainable product. Okay, the roof choice criteria. Yesterday, yesteryear, what did you have to do to determine if you needed a roof? Well, the first thing you did is you had to look at what the installation cost was. What's it going to cost me to replace a roof? And I talk about replacing a roof because one of the main businesses that Parsons Roofing does is we do retrofits. That's our really key focus. We don't do a lot of new construction, but all these rules do apply to the new construction technique. So what's the upfront cost? What's it going to cost me to put that roof on? And then there's the performance record of the contractor who's installing it and the roof system itself. Is the contractor reliable? Has he been around a long time? Does he have a good reputation with his customers? The roof system that he's putting on, how's its performance? What are its maintenance costs? And we'll get into that a little bit. Does it give you the fire, the wind, and the code specifications that are required for the zones or the areas that you're in? Out here we talk about wind zones on a regular basis. What are the maintenance repair requirements? You heard Dr. Gomez talk about budgeting for maintenance and repair of a roof system, because as roof systems age, the older style did have periodic maintenance that had to be performed to them. And then what's the warranty? And how good is the warranty? How strong is the warranty? Well, that was yesteryear. That was 20 years ago. Today, we have to still take into consideration all of those factors, but we have to add a few more too. We have to say, are we going to get any energy savings from the roofing system? What are the regulations that have been put in place? And I'll use a couple prime examples. In 2009, I think it was 2000. Well, when I came through Houston, the city of Houston had just implemented a new code structure, and they said they've embraced the cool roof technology. You had to use 75% reflective, 75% emissive product in a re-roof or new roof application, and you had to have an R19 insulation value above the deck. I can tell you probably 2/3 of the roofs that were placed after I were not to this code structure, but it's something that you have to take into consideration these days. You have to be very careful about checking with those. I've seen many an application that was not done to code and was unable to pass a code inspection. Life cycle cost analysis. What is this roof really going to cost me over the course of either the warranty period or the expected life of the period? And these days, is it a sustainable system? Does it meet the guidelines set forth, the ones that we just talked about, the definition of sustainability? So not only do we have to take care of all of these items here, these days, this is something we have to take a very, very hard look at. Okay. So, high-performance roofing systems, HPRs, that's what we label them. They're basically a high-performance building requires a cool, sustainable, or a high-performance umbrella system. And regardless of what you call the roofing system, it still has to keep the weather out. It has to be leak-proof, it has to be long-lasting, it has to have minimal maintenance, and it needs to be resistant to all weather types, specifically in these areas down here, heavy rains and high wind situations. And it has to be cost-effective to be an accepted technology. It can't cost $10 to $12 a square foot anymore. It has to be in a considerably less than that range and applicable to the area that we're in. So why are cool vinyl roofing systems, why are they sustainable? And there's a couple different reasons. Number one, they have a high age reflectivity. So when you have a roofing system and you put a white roof down, if you were to, and I'll correlate again to the car, the white car sitting in the parking lot, if you left that car sitting out there for 15 years and then you came back to inspect it 15 years later, what do you think the finish would look like? The reflectivity of that finish will have gone down a considerable amount. High age reflectivity means when I install this roofing system, say a Duralast roofing system, I have 88% reflectivity. After 5 years, what is my reflectivity level? After 10, after 15, after 20. It's keeping the reflectivity level up that allows you to maintain an energy efficient roofing system. Low carbon footprint, and I've only heard this talked about a little bit today. The other types of very popular roofing systems that are out there today are TPOs, which are thermoplastic polyolefins, an oil-based material, and the EPDM, or the rubber roofs, ethylene propylene diene monomer. Everybody got that down? That's a joke. Okay. Rubber roofs, black rubber roofs. These are all oil-based products. So they basically have a 100% carbon footprint, where the PVC vinyl systems have about a 50% carbon footprint. So this is following our sustainability lines. Prefabrication. Most roofing systems today that are put onto buildings are not prefabricated. And when I say prefabricated, if that table right there was a roof that I needed to replace, do you go out and you pre-engineer the system? Is it a pre-engineered system that can be installed with a minimal amount of waste, with a maximum amount of prefabrication? Most systems are not. When you have a re-roof done, rolls of material show up, and they just use what they can and they throw away whatever they need to. With the pre-engineered system, that is not the case. Approximately 85% of the work that needs to be done is done prior to the material even arriving at the site. So again, eliminating waste. Is the product 100% recyclable? All vinyl roofing systems are 100% recyclable. And that is through the manufacturing process, at installation, and at demolition. When it's reached its usable life cycle, vinyl roofing systems can be sent back to the manufacturers and recycled for use in either new roofing systems as ancillary components, or turned into other products. And what's the quality control? Roofing systems with high amounts of quality control from a factory standpoint tend to minimize maintenance requirements, thus giving you a better life cycle cost analysis. Okay? Cool vinyl systems, naturally fire retardant. Vinyl, it has a natural fire retardant in it. If you were to light a vinyl roofing system, as soon as you remove the ignition source, it goes out. It does not continue to burn. This is very important in fire-prone areas. Does a sustainable system support multiple PV systems or photovoltaic systems? And I'll show a little bit of those in a little bit. Does it support a vegetative system? And I don't know if anybody is familiar with what a vegetative roof system is. Basically, that's the ultimate green roof. We'll talk about those a little bit down the road here. Is it long-lasting, and how good are the warranties? How solid are the warranties? And when we talk about strong warranties, they're a considerable portion of your life cycle analysis. All right, so the HPR umbrella, the high-performance roof umbrella, and the 5 E's. We'll talk about each one. But basically what they are is energy, environment, endurance, economics, and engineering. These make up the 5 E's of what we call the high-performance roof umbrella. Energy. That's what we've been talking about all morning long. Reduce consumption and improve efficiency of the building envelope. Environment. Reduce the overall impact and the preservation of the external environment, while also creating and maintaining a healthy, productive indoor environment. Endurance. Long-lasting performance. It's as simple as that. Economics. Low life cycle costs. Maintenance costs that are associated with it, repair costs that are associated with it. There are quite a few other things that we'll go a little bit more in depth on here. And engineering. Engineering ties all of these together, and the fact is, how is the system designed and how can it best meet the needs of the building and the end customer? Okay, let's talk about energy first. Cool or green roofing, part of every high-performance building's energy strategy. It's just a must these days. You have to incorporate high-performance systems into new construction and into retrofits of building. If you're spending hundreds of thousands on new windows, new HVAC units, insulation inside the building, everything that you can do to make that building more efficient, then using 50-year-old technology as a roof, you've done yourself a disservice. It's just part of trying to save and trying to manage the energy that these gentlemen have been talking about all morning. All right, cool roofing and insulation combine for an optimum energy efficiency. Cool roofing, again, reflectance and emissivity, and insulation, which is these days in the re-roofing industry and the new construction being mandated to you on what you have to use above deck, underneath the top layer of the roofing system. What type of insulation, what type of thermal R value are the codes that you're looking at? What's required there? And I didn't catch the first part of Jason's presentation this morning, but cool roofing improves HVAC performance. That has been a proven fact by Duralast and many of the other companies for the last 15 to 20 years. And we'll go a little bit more in depth into how a cool roof improves the HVAC performance. And then there's the embedded energy impacts of the environment and the economics. This pretty much says it all right here. What you're looking at is a picture of a Georgia Tech University building that was done with a Duralast roof, or a white cool roof, PVC roof, and this building happens to be approximately 7 years old. So we're looking at aged reflectance here. All right, let's see if I can get this on here. This is the top of the roof system right here. The outerlying building, the parking lot. Air temperature on this day, 93 degrees, 100% sun. Basically, the sun is shining. It's not a hazy or a cloudy day. The membranes, the cool roof technologies with high reflectance all operate approximately 5 degrees above the ambient temperature. That's due to a combination of the reflectivity and the emissivity. You'll notice that the parking lot is at approximately 130 degrees. On a hot day, 95 degrees down here in the valley, sun shining, cool roofs, again, will be operating about 100 degrees. Other styles of black roofs will be operating anywhere between 145 to 185 degrees, depending on the type of roof that it is. Somebody asked me the other day, and I had to look this one up. Why are the trees, these are actually trees right here, why are the trees cooler than the roof? Evapotranspiration. Anybody know the definition of that? I didn't either. Basically, trees, living organisms, have the ability to cool themselves. Didn't know that, but there's a quick little fact that you can take home today. This is a diagram that was done, let me see who put this one out. It was developed by the Lawrence Berkeley National Labs a few years ago and has been widely distributed across, but it's still very, very applicable today, even though it's a few years old. This is a comparison of dark roofs versus cool roofs and the savings potential that they have in the different major metropolitan areas. And basically what they're saying is approximately 40% less energy is required if you're using a high-performance cool roof umbrella versus the old-style dark roofs or black roofs. You guys are right down here. The maximum potential savings can be realized by just replacing the existing roofs that you have as they reach their age limits or their repair maintenance budgets go up so high. You can save approximately 40%. Now, I'm going to buffer that number because it depends on the building itself, and I'll go into a little bit more about that here in just a little bit. But it's still a very good guideline, and these are guidelines that the Department of Energy has embraced, and they're telling all of government entities at this point under their control, you guys have to use this technology. It is mandated to them that they have to use this technology. Okay, let's talk about the environment next. The environment external of the building. What is the real environmental impact of this type of technology? When you talk about the impact of external to a building, there's a lot of different things that factor into that. And one that we'll get into a little bit more is, and I think there's a bullet on here, is the urban heat island effect. Is anybody familiar with that? I mean, folks that have been in energy management for quite some time and read a lot of articles will understand what the urban heat island effect is. Basically, what we're saying is, let's take the roof out of that categorization. Normally, your impervious covers, such as parking lots and things like that, are one of the major contributors to the urban heat island effect. But if you're using a cool roof technology, you're not contributing to that urban heat island effect. And I'll go into a couple of points on this. But when we talk about environment, we also have to talk about life cycle analysis. And it's a fairly complex. I mean, you've got to, if you want to really get into the sustainability side of things, you have to factor in the material extraction cost, the fabrication, waste minimization, hazardous waste, the distribution of the product. Where is it coming from? Where is it being manufactured? Is it recyclable? Does it have alternate uses once it has left or served its usable life? And then the options that go with that. So let's talk about this. Urban heat islands. Every degree Fahrenheit that the daily maximum temperature rises requires 2% more energy. These are numbers that were released, and I forgot the source of this. Didn't give me the source on it, but these are considered the generally accepted guidelines. Smog. Probability of smog rises 5% for each half a degree above 70 degrees. So as power demand rises, where does most of our energy come from? Fossil fuels. We're continuing to increase the urban heat island if we don't do things to minimize that, which is what we're trying to do here with the cool roof technology. Another side effect of the urban heat island effect on non-cool roofs became very apparent a few years ago in a couple of different studies that were done on aquatic life. Rainwater runoff is basically considered to be superheated if it rises 5 degrees above the temperature of the rain itself when it hits a structure. So what happens when you have a rainy day, or it's been sunny, the rain rolls in, your roof is at 150, 160 degrees, let's say you have 100,000 square feet, the rain hits it, all of a sudden that first few thousand gallons that sheds off the roof, it is not at the ambient temperature. It could be as much as 10 to 15 degrees higher, being introduced to the local drainage system, thus raising the temperature of the local water systems. And if you have any kind of habitats around it, again, it can be very devastating. A 5-degree rise can, in a lake temperature over a short period of time, or a holding or retention pond, if there's any aquatic life in there, can introduce basically intolerable stress and kill the fish or the organisms that rely on this water. Basically, what I just got done saying, it's harmful to the aquatic life. Then there's the internal side of the environment. There isn't anybody out there that doesn't understand the problems that mold can cause. If you have a high-performance roof system, a cool roof system, you have two aspects going for you. Number one is it properly ventilated? And most of the systems that we do, and most of the vinyl systems, are a ventilated roof system. If there is moisture trapped inside the roofing or the underlying insulation, it can escape. And also, there we go. Cool roofing helps control the air temperature in the building. I'll go into a little bit more about it later, about HVAC. I mentioned that earlier. But it's something that the internal environment is directly associated with how well the roof is performing itself. It's something that a lot of people don't understand when they talk about internal air quality, but it is a very important factor in that. And also, depending on the type of roofing system that you're installing, the vinyl cool roof high performance systems do not use chemicals. It's simply a hot air welded system, or it is a water-based fully adhered system. Again, there's not the hot tar, there's not the gas associated with it. We're not burning a roof down on top of another one. We're not contributing to the CO2 issues of using flame applied systems. These are all hot air welded systems So again, there's no chemicals used in them. This is kind of an interesting little case study, and you may not think it's not applicable in this situation, but if you think about it, there was a dairy farmer that had a building, and it was an unair-conditioned, ventilated space, but it was a metal roof system. And what they did was we came in and we installed, and I say we as in the Duralast context, we installed a high-performance roof system with additional insulation over the top of the metal building, basically his dairy barn. And they found over the course of a year period that the cows were less stressed, and how you judge the stress of a cow, I'm not real sure. I haven't spent a lot of time around them. But he was able to cut the herd. It resulted in a $44,000 a year savings. The cows produced 10 to 15% more milk. That's probably how he judged that they were less stressed. And you think about that from a standpoint of who would have ever thought about doing this? Who would have ever thought about lowering the temperature so that the cows would be more productive? But there's been a couple of studies done that show productivity of workers based on ambient temperature. So if you're working unair-conditioned spaces and looking for ways to cool the buildings down, high-performance roof systems can actually increase the productivity of the folks that are in there. We did and this was an application that we did. We have done, approximately 75 to 80% of the buildings out at Fort Hood. And some of the largest projects we did were their aviation hangars. We went in and shot the upper side of the aviation hangar, the underside of the ceiling, with heat guns, thermal imaging guns, and we found that the underside of the ceilings were operating at about 120 degrees. When we finished the project, the underside of the ceilings were operating at ambient temperature, or a little bit below if there had been some during the morning times when the buildings were still cool. This created a much more pleasant environment for the soldiers and the aviation mechanics that were working and caring for these helicopters, and morale improved greatly with inside these specific units. Again, the roofs were worn out. They had to replace them anyway, but they went with the cool roof technology and benefited everyone else within that group, that aviation group there. This is a term and a statement that gets bantered a lot around out there. Someone will come in and say, I've got a roofing material and it has an effective R value of R9. And unfortunately, insulation is not rated by effective values. It's rated by its real value and its ability to keep heat from transferring. But we use this statement, improves the insulation effectiveness 25 to 50%. If you have a metal deck, 3.1 inches of they've changed the thing a little bit here, 3.3 inches of polyisocyanurate or iso insulation, and then a cool roof technology across that, you have basically an R20 value above deck insulation system. If the surface of that roofing system never exceeds more than 5 degrees above the ambient temperature, you're effectively giving your insulation from 75 degrees, let's say it's an open plenum system, 75 degrees to 90 degrees with an R20 value, versus the old style of roofing technology where you had 3.3 inches of insulation and 150 degree temperature. You're basically saying, I'm not going to let the roof temperature get higher, therefore my 3.3 inches of ISO is going to do a considerably better job. It's also not going to age as bad over the course of 15 to 20 years due to the excess amount of heat that it has had to keep out over the course of time. So when people banter around numbers, we have an effective insulation value. Be aware, but understand what they're saying is actually true. It's just they might be saying it not quite right. Increase rooftop cooling equipment efficiency. Okay, we talk about high SEER units, heat pumps, fantastic, love them. Chill water systems in the right application, but not specifically. Not water cool towers down here. I'm an old HVAC engineer and an old building control engineer, so I understand these things way more than I probably should. But air conditioners are normally rated, and guys, please correct me if I'm wrong, at approximately 95 degrees, 95% relative humidity. That's where they do most of their testing at, and that's where the efficiency ratings are added, or basically published at. When you have an old style or a non-high performance, non-cool roof technology, most rooftop applications have direct expansion systems, full package units or condensers sitting on a rooftop, sometimes directly on the roof, other times elevated on curbs, and can be, most average condenser height is approximately 30 inches. I have made multiple measurements on old style EPDM and built up roof systems where the condenser coil inlet air temperature was in excess of 125 degrees. You lose efficiency if you're not operating at the ambient temperature. So you're not going to make your rated tonnage of the unit, or the unit is going to run continuously, thus, well, using considerably more power. I have a very specific example. I installed a roof up in a little school district called the Bushland School District out of the Amarillo, outside of Amarillo, a couple of years ago. And the superintendent called me after the roof system had been in about 3 months, and he said, "Phil, I think you guys broke our air conditioners." And I said, "Don, I'm not too sure what you're talking about." He goes, "They're going on and off. Are they supposed to do that?" And I said, "Yeah, Don, that's what they've been supposed to be doing for the last 10 or 15 years. I said, "Every time one of them switches off, you're saving money." "You know, the room's cool?" He goes, "Oh, they're great, no problem." A lot of times when engineers and architects design roofing systems and then they add the air conditioning systems to it, they don't take into consideration the amount of heating that occurs on the roof. There are many applications where you may have very poor wind circulation due to high parapet walls or units next to walls, and they can exceed 140, 150 degrees at the units. They're never going to perform as they should in these situations. But when you use a high efficiency, high performance cool roof system, they're normally operating at 5 degrees above. And if that average height of 30 inches on the condensing coil, it's normally ambient temperature. And I carry a temperature gauge with me to show people what we're talking about. It's amazing the difference, which is why when we do a cool roof system, if it is, I'm going to give the perfect application for a cool roof system. Single story building, large basically plan form, parapet walls, multiple direct expansion package units, typical elementary school is what I'm talking about. We normally see 20 to 25% savings on those at a minimum with no other changes to the system. We're just allowing the air conditioning systems to run more efficiently and not transferring the amount of heat into the open spaces below that the old style roofing systems do. So very key factor. Find my button. I talked about this earlier, reduced deterioration of roof substrate materials. If you have something sitting at 90, 100 degrees underneath the membrane versus 160 degrees under a membrane, everything is subject to temperature cycling. Even inanimate objects, when they temperature cycle, they age. If we reduce that temperature cycling, we reduce the deterioration of the substrate underneath. And I'm talking mainly about the insulation, and it could be also the decking material too. Non-cool buildings, this was our cow example a little bit earlier, how we can reduce the temperature interior due to the fact we're not radiating heat through the system. Okay, endurance. How well can a system last? Can it go the distance of, let's just pick an arbitrary number, the warranty period. Most roofing warranties are anywhere between 15 to 20 years. Can it go the difference, or can it go the distance and continue to perform? Longevity is a key factor of a roofing system. All right, what makes for good endurance? Number one is the design of the material itself, the design of the roof system itself. Materials, structure, and code compliance, they're all very, very important, and you have to follow them, and sometimes you have to make concessions on the roof system when you're dealing with code compliances. Also, the design includes drainage and penetration. Key factors to any roof system: how well does it drain, and how are the penetrations handled? Almost all leaks occur at a change of plane or at a penetration. It's just due to thermal expansion, contraction of the roofing system and the building itself. All right, and I'll add one other thing down here: warranty. Is it a complete versus a partial installation. Is it a complete versus a partial system? Did we do the whole roof or did we just do part of it? That's going to mean when you tie two different roof systems together, you don't necessarily have the best seal that you can have right there, and one will affect the other. Contractor competence and labor intensity. A roof is only as good as the contractor that installs it. So does the endurance is specifically related to the competency of the contractor and how simple is the system. It's a very complex system. You're going to have endurance issues with that roof. What's the performance? Water, wind, fire resistance. Was the system designed correctly to meet the local weather is basically what it boils down to. Extremes of heat and cold, wet and dry, continuous temperature cycling. The roof can reach 100 degrees during a day, yet a storm comes in and all of a sudden it's being shocked down to 65 or 70 degrees. Can it handle those extremes? Can it be completely inundated with 6 inches of rain and bounce back and be, have hot sun the next day and instances of ponding water? Can it survive that? The warranties. Warranties are, they run across the board, but they're a good indicator of what to expect, and I've got a specific slide on this. We offer on our systems, we offer 15 and 20-year warranties, and they're what's called NDL warranties, and those basically mean no dollar limits. So when you have a no dollar limit warranty, 14 years down the road, if the roofing system fails, and our warranties cover installation, if the roofing system fails due to installation or material, we replace it at no charge. There's no dollar limit. Yes, in 15 years the value of that roof has gone up, but it's still replaced at no charge. That's one of the strongest factors in a warranty. 77% of building owners say this is the most frequently unmet need. 77% of the people said their warranties failed them for whatever reason during the warranty period. And a statement that we like to make and that I'm very adamant about, and if you look at our warranty here, that's it. That's my 15-year warranty right there. The large print giveth and the small print taketh away. This tells you what I'm going to try to do for you. This tells you what I'm not going to do for you. If you get a warranty from a roofing company that has small section of what I'm going to do for you and 15 pages of what I'm not going to do for you, I guarantee you, you're going to be one of these guys right here. So a high-performance roofing system has an extremely strong warranty because the manufacturers stand behind their product. Maintenance. In yesteryear, every roof had maintenance associated with it. In fact, to maintain the warranty, you had to follow the maintenance schedules laid down by the manufacturers themselves. This meant recurring inspections, possibly recoating, regranulating. It could have been anything. These things have to be factored in of the amount of maintenance that a roof requires is directly reflective of how long it will last. High-performance cool roofs basically are maintenance-free. They do not require a maintenance budget, which Dr. Gomez talked about a little bit earlier, and they do require no more than yearly inspections by your personnel to make sure the drains aren't clogged and that the drainage is doing what it's supposed to do. There's no bottles in the scuppers or the downspouts, and that you don't have an accumulation of debris on the roof from trees or things like that. How easy is the roof to get to? Accessibility and ease of repair also are real key factors of the endurance of a roof. And the track records of the materials themselves. How has the roof performed in other applications? There's thousands and thousands of case studies out there that you can look at from the different manufacturers. And all the manufacturer sites are going to give you all the good ones, everything that went right. But there are other places that you can look for track records. I'm going to take a specific example. I'm not going to knock the product. TPOs, the thermoplastic polyolefins, were introduced about 15 years ago. After about 5 years, they were subsequently pulled off the market and then reformulated because of major lawsuits from folks like Walmart and Home Depot, who were big users of this initial technology. That's a track record. that says we didn't do so well the first time around. So that's going to be a major factor in the endurance of a roof system. The economics. High-performance roofing systems cost less over time. It's a simple fact. If you have an energy-efficient system that's saving you money, if you have no maintenance cost associated with it, very low repair cost if they are damaged, you have a system that, although the initial cost may be higher, it can, over the course of time, actually pay for itself. And this is where the life cycle cost analysis, most people, when they get they say, and Dr. Gomez was talking about this, oh, we need a new roof, God forbid. I get 5 bids. I get a bid from ABC Roofing, and then I get a bid from Parson's Roofing. Good gosh, look at Parson's price. They are 30% higher than these guys. I wonder, well, we're going with the low bid. Okay, the low bid may not be a high-performance, energy-efficient roofing system, and over the course of 15 to 20 years could cost you more. In fact, if you're not installing a high-performance, energy-efficient roof system, you are just putting down and putting out money for a capital investment. There's no ROI associated with it. All high-performance roofing systems have an ROI associated with them. They can, in certain applications, pay for themselves over the course of the warranty period. Old-style, non-high-performance roof systems cannot pay for themselves. Again, it's just money that you're putting in the building that you cannot recover. And in fact, most of the time on the older-style systems, at the end of their useful life, you have to tear them off. All right, so you have to factor in, the material, the installation labor, maintenance, repair, tear off, and disposal costs. These can be enormous. We're down at a conference about sustainability. What is sustainable about an old-style roof system that you have to tear off and throw in a landfill? That is an oil-based product. What's it doing to our ecosystem? This is why we promote, and when we do systems like this, we promote them as recovers. We don't, under certain circumstances, have to tear off the existing roof system. We can go right over the top of it. Give you a high-performance roof system and not fill the landfill full of your old roof and not lose the insulative value that it still does have. And again, we talked about this potential for energy savings. Whoops, wrong button. Engineering. I don't know how many of y'all have ever talked to an engineer from a roofing company, because there normally are no engineers in roofing companies. I know you guys have been inundated with engineers today, and I think there's actually maybe 1 or 2 more on tap for today. This is what ties everything together, the first 4 E's, and makes high-performance, sustainable roof systems. The fact that companies like Duralast put forth the effort to engineer their systems. I don't have to go out and get a licensed professional engineer to get a WIN to install a system, except if it's a WIN certificate required system here in the state of Texas, because Duralast signs off on all of the systems that they do. Pre-engineering, engineered for long-term performance that saves money, energy, and protects the environment. How do we do that? Custom prefabrication. If you have perfect example right here. Every roof has pipe stacks sticking through it. When I go measure a building, or when I look at a building, I measure that down to the 1/4 of an inch. And I tell Duralast, guys, here's what I want you to do. I've got 14 pipe stacks, they're 1.5 inches diameter. I need 14 boots to go on those. They pre-manufacture those for me. I do not field fabricate those in installation, okay? Again, where's the #1 leaks associated with a roof? At a change of plane or at a penetration. All prefabricated items. And this is a key thing for reducing the overall cost of the roofing system, okay? Closed loop manufacturing. If you're ever to take a tour of a high-performance roofing manufacturer, one thing that you would notice is there's no waste in these manufacturers. Everything is recycled, and it's an entire closed loop within the system. I'd love to take everybody in here for a plant tour up in Saginaw, Michigan, and maybe one day, a few of you will take me up on that. It is an amazing closed loop manufacturing system. It's unbelievable. No waste in the manufacturing. That's part of being a closed loop system. And quality control. Some of the highest in the industry. You can't have a high performance roofing system and have no quality control. You have to have high quality control. This allows you to issue some of the best warranties in the business. Okay. All this sounds good. Phil, you come up with some great ideas here, all the different things. But what does this really mean? And how do you apply this in the practical world of where y'all are sitting out here? You can listen to me talk and all day long, but how do you guys apply this? How do you what do you take away from this right here? Okay, so we've decided, all right, we need to replace a roof. And we want to use a high-performance system, but we want to make sure we know that it is a high-performance system. All right. First off, is it an Energy Star rated system? All right. Most vinyl, and specifically the Duralast, are an Energy Star rated system. Does it meet the ASHRAE 90.1? I'm not going to go into these standards. Does it meet the the Energy Star criteria? We're not in California. This is a nationwide, but basically what Title 24 says, it specifies a minimum of 75% emittance and 55% age reflectiveness. Those are guidelines that you have to follow if you're getting a high-performance system. Does it qualify for any local incentives? And this presentation is a couple years old. There used to be all kinds of incentives for reflective roofs. Well, we've rewritten most of the codes, and now they force you to use them, and they don't give you anything for it anymore. Now, there are areas that are, and I know that there are some, and you guys might be able to address this. We've worked with Clear Result before in getting some rebates in some different companies. I know that some of the energy producers still do offer rebates on reflective systems. Most of the metropolitan areas, and specifically places like Houston and the Austin metropolitan area, they mandate 75% reflective, 75% emissive, and R20 above the deck. So these don't always apply here. If they do, great, and we'll be happy to work with you guys on those if they do apply. Highly reflective system. That is a key thing for energy savings. Cool roofing. It keeps the building and the cities and the surround, reduces the urban heat island effect. It reduces the energy demand, and it mitigates the heat islands. These are key things on the first section, okay? These are also, almost all high-performance roofing systems are compatible with photovoltaic systems. I don't know how many that anybody, has anybody in here done any photovoltaic systems in conjunction?
Some in the parking lot.
I saw the ones out there, but are any of them rooftop mounted applications?
There's some, I know there's some, Cumberland County has.
Okay.
TSTC did it on the, did they do that at the articulation building?
Okay. It's, photovoltaic systems are, as they become more affordable, we're heavily looking into them as a roofing company. I mean, we're there already. We might as well help get involved in this business because we understand the needs that these systems have in terms of making them compatible or making sure the roof system is compatible with the photovoltaics. And if you look at a rack-mounted system like this, every one of those is a penetration in the roof system. Where do roof systems most likely fail? At the penetrations themselves. All right, then you have the ballasted systems where they're done, and this is a nice one. This is a real nice system. They actually had poured concrete blocks here. Most of the time you see center blocks of bags of concrete. Again, these require a specific type of interface to the roof system that you see underneath the block here. These are walk pads. We manufacture a 90 millimeter thick corrugated system that goes underneath that to protect the roof system itself. Again, very easy to use, and these are very simple systems to install. I don't know the requirements down here for the wind zones on these, but it bears checking into. But that's something that a high-performance roof system has to be capable of. And then there are the adhered systems. There are photovoltaic manufacturers out there that make these with a specific backing on them, and we glue them directly to the roofing system itself. And they become a permanent part of the system. Oops, wrong thing. So that's our checklist for energy. Our checklist for the environment, again, EPA Energy Star label. Does it meet the green building certifications? Are you going for LEEDs? LEEDs is expensive. It's a selling point these days. It's a banner up that it says we have gone this way, but let's face it, it costs. And that goes back to the profitability thing. We're out here, Duralast is manufacturing, we're installing a very cost-effective system, but you have to pay attention to things like the LEEDs if that's what you're going for when you're looking for this, if that's what you're after. Recyclable material. Again, all vinyl systems are fully recyclable. Is a roof tear-off required? International building codes from 2009 state that you can put 2 roof systems on top of an existing decking material. They don't specify what those 2 roofing systems are. They could be 2 built-up roofing systems, they could be 2 single-ply roofing systems, but you can, following the international building codes, put a second roof over an existing roof. The only times that we don't do this are if the existing roof is saturated underneath, the insulation is saturated with water. That causes major issues down the road with deterioration of the insulation itself and of the decking material and consistent leaks for a period of time in the building. That's the only time that we tear a roof off, or if we find that there is a situation where the deck is rotted out or there's just something wrong that we have to address underneath the roof. This is a big thing when it comes to environment. Again, we're trying to promote folks to keep from filling landfills up with old, perfectly good insulation. All right. Interior temperature and air quality. What are you trying to maintain? And again, the scrap and the landfill burden. Green roof systems. Anybody have any of these? These are the vegetative roof systems I was talking about earlier. They're popular in places like Austin, downtown Houston, and where we see most of them, right here. You have a row of offices right here. You have a hotel rooms right here, windows looking out. For some reason, the occupants in the building there, and I know I'm going long here. I'm sorry. I'm going to blow through this. They don't want to see a white reflective roof. You still get all the benefits. Plus, you get a little rainwater collection off the top of it. So, different types of systems that we have out there. If the roof is part of an active portion of the building, like this area here, the Duralast roof system is under this, but then we have these PVC pavers over the top of it and a grid system right here. Endurance, manufacturing contractor reputation. How does the roof going to survive? What's the warranty? How long does it last? Exclusions. Remember what I said, fine print taketh away. Careful of systems that exclude ponding water. I don't see too many flat roofs that don't have ponding water issues. Does it offer warranty on the installation and the material itself? Most warranties are contractor warranties, not manufacturer installation warranties. Good high-performance roofing systems, the manufacturer stands behind the installation in case the contractor is not around in 5 to 10 years. And what's the maintenance repair schedule? How much is it going to cost, and how often is the manufacturer requiring you to do something? All right. Training and inspection. All right. Economics. Look at the life cycle cost. It's not just the installed cost. Maintenance repair cost, tear-off cost, recycling cost. There's a lot of things that go into what a roof really costs. Recycling. Again, I talked about this. If you're trying to do a sustainable roof system, that roof system has to be recyclable. Engineering, we talked a little bit about this. Optimum for the needs, meets the codes, is wind resistant, is fire resistant. Says it all right there. PVC, TPO, thermopolyolefin, oil-based product, EPDM. Take the flame away, this is what happens. This is in certain areas that have wildfire, this is becoming mandated that they use a self-extinguishing system. PVC is a natural flame retardant. A high-performance umbrella for high-performance building systems. That's what we're striving for. A sustainable product that is actually not just a capital investment, but is an asset to you, the company, your organization, your institution. And that's it. I'm sorry I ran so long, guys. I could have gone at least another hour. Anybody have any questions? I must be the smartest guy in the world then. Yes, sir.
You talked about reflectivity.
Yes, sir.
And down here with the burning of the sugar cane, all roofs in about 5 years is black. You know, is that going to require a wash down every so often? Same thing for reflectivity, or does it automatically rains and just goes out?
Actually, with the system that we do, we have seen this, but when we do have regular, consistent rains, it does wash the material off. Most PV systems are pretty much impervious to any thing leaching down into them. We do see applications where we have mold or mildew, but it's actually adhering to the dirt that's stuck on the roof itself. A good example was Cameron County Airport. I went up there, its roof's been on about 6 or 7 years. I thought, man, this is kind of dirty. Well, I got a little broom out and got a hose. I washed off part of the roof for them. It was completely white underneath it. The roofs are very easy to clean. In fact, I do know some school districts, because I do mainly schoolwork, I do know some school districts that is the football team's summer project, cleaning roofs. Yes, sir.
Down here, during the fireworks season, there's some bullet holes up in the roofs, you know, maybe like 5, 10. Is it something that can be repaired with a small patch without compromising the warranty of the roof?
Absolutely. Almost all single-ply systems, an individual patch on a bullet hole, and I see bullet holes constantly. An individual patch for a bullet hole is about this big. It takes approximately 5 minutes to apply, and most good contractors like Parsons, I'm gonna leave you with some simply applied patches by the maintenance department, and then we'll come back in and do a repair for it. And it's very, very easy to repair it. In fact, a lot of folks, we've even trained their maintenance personnel to do it. Again, it's a hot air welded system, so it's very simple to fix, and it does not infect the integrity of the system. When you place a patch across the single ply membrane and you weld to that, that becomes actually stronger than the surrounding material. No warranty considerations on it at all if it's done correctly. Yes, ma'am, you had a question.
Mine was a comment. In New York, last year, as a volunteer initiative, they called it Cool Roofs, and they had several volunteer organizations, go and paint the rooftops from several of the skyscrapers or the skyscrapers. And so it was a huge initiative, and now they're evaluating, and this was just the paint that they put over it, they're evaluating the energy cost savings for these buildings, which I thought was a really neat concept. I've always thought the cool roofs was a really neat concept. This was just paint, that's as far as they went.
We see that on a regular basis. Somebody that's just has heard about the cool roof technology, trying to improve the efficiency of their older style roof, if the roof is not in need of replacement or they just simply don't have the budget to do it. There are a lot of different coatings out there that you can put on a roof that can get up to about 75% reflectivity. Unfortunately, they don't increase the emissivity of the underlying roof, so you don't get the maximum benefit out of it. But I tell anybody, again, it's a situation, black car, white car. Which one are you going to put your hand on in the summertime?
My other question was, what about historic rooftops? For example, we have a museum that's currently getting a roof rehab, but you know, you have to have the original clay tile and whatnot. So what route would you recommend to become a more energy efficient roof?
Okay, we have done, I personally have done about 5 different courthouses and a couple of different historic buildings. Most recently, we just did the Duval County Courthouse up in San Diego. The National Historical Society has very, very strict guidelines on what you can and can't do. Almost all historical buildings have had the roof replaced multiple times, and most of the time they haven't followed the guidelines. But in a situation where you do have that, we'll address everything up to the point which cannot be seen from the ground, which is an integral part, and we have learned very specific techniques, and the single plies are really good about tying into existing roof systems like the tile or the copper roof systems. We can deal with that without affecting the appearance, and the National Historical Society says, they sign off on it. They say, this is fantastic, you guys did a great job. It's very easy to use this type of product in those applications. Well, thank you all very much.